Welcome and Namaste. I welcome you to the second introductory lecture, the continuation of a glance on the syllabus. In the last introductory video, I have given a brief outline on the Unit 2 electrochemistry. In this introductory video 2, I have to give you a glance on fundamentals of X-ray crystallography. What all the things you are going to study in the fundamentals of X-ray crystallography. Right now, I shall start my slideshow. Yes, the fundamentals of X-ray crystallography, the Unit-III, which is of 16 hours topic, which includes the concepts of law of interfacial angles. What is this law of interfacial angles? As you know, the crystal is a perfect solid where the atoms are arranged in an repetitive and regular manner in a three-dimensional way. Such arrangement of atoms are there in a crystal, and such type of solids are called as crystals. Arrangement of these ions or atoms or molecules in this crystal leading to a particular geometry. Hence, the crystal has to exhibit a kind of a structure. So, determine this structure of a crystal, the technique by using X-ray diffraction, hence the study X-ray crystallography. So, the basic concepts of X-ray crystallography or the basic concepts on the crystals, it comes or started from the solid. What are solids? The types of solids, that is crystalline solids and amorphous solids. What are the properties of crystalline solids and amorphous solids? And what are the different concepts like what are unit cells, lattice, basis, lattice plane, and what are the Bravais lattices? That all you have studied in the previous undergraduate courses. So we have to commence from the concept called as the law of interfacial angles. As you know, why this concept of law of interfacial angles comes in the solid state is we have, we have what is called as different phases are there, right? These different phases, right? This is one phase, this is another phase. Like there are two different phases when they are connecting together to form an angle, right? That angle is called as an interfacial angle. The interfacial angles of a different geometries of a crystalline solids may exhibit some similarities. Hence, the law came into exist called as law of interfacial angles. This law of interfacial angles is originated after the different types of the crystalline structure solids have been looked into it. Then the second concept is called as law of symmetry. The term symmetry is not a new. Symmetry term is known to you very well, where the objects in the nature, it exhibits a wonderful property called as a symmetry, where the similarity between the two parts of the object or various parts of the object. You know about axis of symmetry, you know about plane of symmetry, you know center of symmetry, right? And the other symmetry elements called as identity and improper axis of symmetries. Why the concept of symmetry is comes into picture while studying the X-ray crystallography? The X-ray crystallography is mainly the study or the deducing the internal structure of a crystal. So the different classification of the crystals or the different types of the crystals mainly classified on the basis of their 7 crystal system and Bravais lattices, and further these crystals are being classified into 32 space group mainly on the basis of the symmetry. So the study of law of symmetry is a very essential criteria while studying the or deducing the X-ray crystal structure. Then the Miller indices. What is this Miller indices? You know, as I said, this maybe one structure. I will draw the another. Say for example, I will draw a simple cubic. Right? When you write a cubic structure, right, there are different planes may be present in this structure. You know already what are the planes: 100 plane, 111 plane, 122 plane, or 211 plane, 200 plane, 400 plane, 311 plane. You have already heard about these planes. These planes are present in a particular geometrical structure of a crystal, and these planes are oriented along the lengths of the unit cell dimension A, B, C and the crystallographic axis X, Y, Z respectively. And hence, identification of the orientation of the crystal and indication of such planes by using HKL value along the length of A, B, C with respect to the crystallographic X, Y, and Z axis is very essential, and it makes a very fundamental aspect before going to study of the what is called as the experimental method. So the Miller indices is give a indication method to indicate the type of the planes present in the crystal structure by the value, the 3 values called as HKL. Yes. Then, before going to this experimental methods, we have another study called as the Bragg's law that I have not mentioned here. What is called as a Bragg's law? We don't have derivation. We are not going to derive this Bragg's law, but you know that the Bragg's law makes a basis to deduce the structure of a crystal when you are going to determine the X-ray crystalline structure by any of the experimental methods. W.H. Bragg and W.L. Bragg, a father and son, have received a Nobel Prize for deducing the structure of NaCl by their own X-ray diffractometer, and developed a very simple equation and a very well-known equation called as n lambda is equal to 2d sine theta. Right? In this equation, you know, n is order of the reflection, lambda is called as a wavelength which were used in the experiment, and d is called as interplanar spacing, and theta is called as a diffraction angle. So this Bragg's law we need to understand before going to study the experimental methods. In experimental methods, what we are going to study is there are different experimental methods, but we have rotating crystal method, that is single crystal rotating method, and powder diffraction method. How do you determine the single crystal structure? By rotating crystal method, that is called as a Bragg's diffractometer. And after obtaining the picture of a crystalline structure, how do you index those pattern which is being obtained from the rotating crystal method? That is what indexing of a crystal photographs means. You have kept a single crystal in the instrument. You are incidenting the X-ray beam onto it, a monochromatic X-ray beam onto it. Then when it goes and touches or experiences the plane, if the plane contains an atom, and if the X-ray meets the obstacles like an atom, it undergoes a scattering, means a reflection, it takes place, and a particular reflection will be appeared as a spot on the photographic film. So what that spot indicates, that interpretation of that spot, which from which plane it has come out, that is called as indexing of crystal photograph. Then powder diffraction pattern. Powder diffraction pattern is where you are not having a single crystal of the sample, where you have a crystalline powder, that's called as a crystallite. In such case, we are using powder diffraction method to deduce the structure of a crystals. And how we do conduct experiment with the powder diffraction method, and after getting the powder diffraction pattern, how to indicate the each spot into a respective plane, that is called as indexing pattern, and finally deducing the structure. Okay. Then after having studied the indexing from rotating crystal method or from powder diffraction method, from any method you can index, you have a spots of that. And each diffraction spots may be having, or each peak which you are going to obtain in the spectrum like this, these peaks do not have a similar intensity, right? Why there is a difference in the difference in the intensity of the peaks, or difference in the diffraction spots? It's because of the atomic scattering factor. Because in a molecule, there may be a different atoms. These atoms may have different electron density in it. Hydrogen have only one electron, whereas iron have 26 electrons. Cobalt have 27 electrons. Zinc have 30 electrons. Likewise, the different atoms do have a different electron density. When the X-ray comes and falls into atom, depending upon the electron density, the scattering intensity would become different. So, while deducing the peak intensity, we have to look at the atomic scattering factor, and we have to collect, since there are different types of atoms, or atoms in a crystal, in a unit cell, and we have to collect these atomic scattering factors, and together we can deduce the structure by the structure factor method. When you have a structure factor method, then we can subject it to the Fourier synthesis analysis, because the waves scattered by a different atoms. See, this is a wave scattered by one type of atom. This is another wave scattered by another atom. This is a wave scattered by another atom. These waves may undergo intervention among themselves, and how to separate these waves scattered from A atom, scattered from B atom, or scattered from C atom. That is what a mathematical method called as a Fourier synthesis or analysis, and thereby we can draw an electron density diagram. In turn, it will able to deduce a crystal structure from this Fourier synthesis and electron density diagram. Then, this is all about the fundamentals of X-ray crystallography. Up to this point, you will be studying. Okay. Then, in which type, for which sample you are not going to deduce the structure of a sample from the X-ray diffraction method, Such sample can be studied by electron diffraction of a gases. Say for example, hydrogen atomic scattering intensity is very, very less from X-ray diffraction method. While reducing the X-ray structural analysis, the hydrogen atoms may be missing out because of the very, very feeble intensity. In such case, we can have a electron diffraction technique. So through that technique, where you can get a deduce the structure of a sample, where you can not determine the structure of a crystal from the X-ray diffraction technique. Then what are we studying? Experimental technique, scattering intensity curves. Scattering intensity curve means how the X-ray peaks are going to appear in the spectrum, and with respect to that, what is the intensity for each peak, and we are going to analyze these peaks to characterize a particular sample in a molecule. Then Whirl equation is a very, very important and vital role in the electron diffraction of a gaseous studies. We don't have a derivation for Whirl equation. We will take a final equation to determine a bond lengths and bond angles by the technique called as radial distribution method. So this radial distribution method, by using a Whirl equation, you can determine bond lengths and bond angles. Say for example, I have a methane, say for example, right? What is the CH bond length? What is the this HCH bond length? Okay, and what is this HCH bond length can be determined by using this equation. Then types of imperfections. How do you say that when the crystals are perfectly solids? It is a continuation of the again solid studies. When you say the crystals are perfect arrangement of the atoms in three-dimensional arrangement, apart from this perfections, there are also some imperfections or the defects can be experienced by the solid structures. And what are the classifications of imperfections? There are different types of defects called as point defects, Schottky defects, and Frenkel defects. It may be because of the original character of the arrangement of the atoms, or it may be originated from the impurities present in the solids. And disordered crystals, line defects, these are all different types of the classic imperfections. Dislocation types, plane defects, small angle and large angle boundaries, stacking faults, crystal growth and fining, and non-stoichiometry. These are all the things you will be studying under the imperfections of a solid. And finally, any solid which you are going to synthesize in the interest of exhibiting a particular kind of properties. Usually these solids may exhibit electrical properties, optical properties, magnetic properties, thermal properties, and mechanical properties. Nowadays in material science and in nanotechnology, the people are thinking about the enhanced properties of a electrical property, or maybe optical properties, magnetic property, and thermal property. You know that what is electrical property? The electrical conduction of a material, how to improve the electrical conduction of the material. Say for example, optical property, that is the refractive index, you know, when the how it reflects light. And a magnetic property, you know, how it is influenced by the magnet, right? That is a magnetic property. And thermal property means it may be how it will be heat resistant. That is a thermal property. And mechanical property, there is a solid, when you have to hammer on it, or when you have to keep the things on it, how it has to withstand that stress and strain, tells you about the mechanical properties. So all these properties will be studied in detail under the physical properties. Okay, thank you very much for this. Is all about introductory video on the syllabus. Now you have, in this introductory video too, you have we have looked into the very briefly on the syllabus which we are going to cover in the future lectures. Okay, hope some of the points may be highlighted in order to recall the previous things which you have studied on the undergraduate or in the +2. Now who can go ahead with all these the previous concepts to understand the better understand of the topics is concerned. Okay, thank you very much. Have a nice time.